Hello, in this video we will be talking about control charts. So control charts are very important. So there are different types of control charts we have. So a typical control chart consists of the following three horizontal lines, which is called a central line. The second one is the upper control limit or UCL, and then is the LCL, lower control limit. The major parts of the control chart is the quality scale, plotted samples. So let me just show you that. So the chart look like this. So this is a quality scale. This is the UCL thing. And this is the LCL. This is the CL or the average. And here this zone is called the out of control zone. There are 3 sigmas. This is also 3 sigmas. And this lower part is also out of control zone. So all the statistical controlling is done in this part, and this axis is called sample or subgroup number. Okay, so this is how it look like. So this quality scale is a vertical scale, the scale marked up according to the quality characteristics of each sample. The plotted samples are the qualities of the individual items of a sample, are not on our control chart. This is the thing. The horizontal lines, which is here like this, are the central line representing the average of the samples of the plotted on the chart, and the line above the central line shows the upper control limit UCL, which is commonly obtained by adding 3 sigmas to the average. 3 sigmas means mean plus 3 into standard deviation, and for the lower part mean minus 3 into standard deviation. So this is the total structure. So UCL equal to the estimated value plus standard deviation of the t. Okay, if we are calculating the sample distribution of t, LCL will be ET minus 3 into AC of t, and CL equal to only the estimated line or the average line. Okay, now what is this 3 sigma control limits are being calculated? It's actually given by Dr. Shewhart first, and here if t equal to t of x1 x2 xn, the function of observations of x1 x2 xn, and e expectation of t equal to mu t, and variance of t is sigma t square. So if the statistics t is normally distributed, then the fundamental area property of the normal distributions, we have the probability of mu t minus 3 sigma t less than t, mu t plus 3 sigma t equal to 0.9973. okay, so now from this thing, t minus mu t taking into modulus 3 sigma t equal to 0.9973. now so probability of t minus mu t modulus greater than 3 sigma t is equal to 0.0027. Remember that I've changed from less than to right greater than, so this also 1 minus 3. So in other words, the probability that a random variable t goes outside the 3 sigma limit is this. So a random variable goes outside the 3 sigma limit. Is given in this way. So this is all about the control limits of this.